Swagatam, Kapadi Mathematics classes. Gurubhyo Namaha. This is your Murali Krishna. This is the third video on the chapter Trigonometry. In this video, I am going to discuss about trigonometric ratios and the relation among different trigonometric ratios. Of course, I am going to do some numerical questions also. Let OA be any initial rate. Let OP starts from OA and revolve into the position, say OP, to trace the angle AOP. So here OA is initial ray and OP is a revolving ray. It came to the position OP. Now this is angle. Angle AOP is equal to, I use the symbol theta. Now remember, this theta is less than 90 degrees. So in this chapter, we are going to consider only angles less than 90. From point P, a perpendicular line is formed. It means, let's say, for example, M. So this OMP is a right angle triangle, and right angle is at M, and angle AOP is equal to theta. Angle OMP is equal to 90 degrees. Now I want to observe the ratio between the pair of sides of the triangle for different values of the angle theta. What is the meaning of that? Now the side PM, the side PM, we say that it is opposite to angle theta. Therefore, this PM is called opposite side. Whereas this OM is adjacent to theta. So this OM is adjacent side. And whereas you know very well this OP is a hypotenuse. Now I want to observe the ratio between the pair of the sides of these three. I want to observe, is there any relation between the angle theta and the ratio between opposite side hypotenuse, adjacent side hypotenuse, or opposite side adjacent side? This is my lesson. Okay, now I have a right angle triangle. This is A, B, C, and the angle is theta. Let the side AB is denoted by the symbol X, letter X, and the length of BC is Y, and length of AC is equal to R. Now here the length of opposite side of theta is Y, the length of adjacent side of theta is X, the length of hypotenuse of the triangle is R. Now I am going to mention 6 trigonometric ratios which are observed in trigonometry. There are 6 trigonometric ratios. What are they? Trigonometric ratios. Now I am going to name them. I am going to discuss this. The ratio between opposite side and the hypotenuse, that means BC by AC or y by r, just name as sin theta. The ratio, the name of the ratio is sin theta, is nothing. And whereas AB adjacent side and AC hypotenuse, which is x by r, is equal to cosine theta. Shortly we call as cos theta. Co means complementary of sine. In the next chapter, I will explain what is the meaning of that. The next one, BC, it is opposite side. AB, it is adjacent side, is nothing but y by r is equal to name tan theta. This sin theta, cosine theta, tan theta are just names of the ratios. And of course, these are the real numbers. And we have three more, that is just reciprocal of all this one. AB by BC, that means y by x. X by y is equal to cotan theta. Next one, AC by AB, which is equal to r by x. Name as secant theta. And finally, AC by BC is equal to r by y is equal to cosecant theta. So basically, there are 6 trigonometric ratios. Sin theta, opposite side by hypotenuse. Cosine theta, adjacent side by hypotenuse. Tan theta, opposite side by adjacent side. Cotan theta, adjacent side by opposite side. Secant theta, hypotenuse by adjacent side. Cosecant theta is opposite hypotenuse by opposite side. These are the 6 trigonometric functions of ratios. Please take that. Now, I am going to establish the relation between any two sides of the trigonometric ratios, any two trigonometric ratios. I am going to establish the relation between any two trigonometric ratios by first observation. If you observe carefully, the first ratio and the last ratio, sin theta and cosecant theta. Sin theta is y by r, cosecant theta is r by y. These two are just reciprocals to each other. Then if you multiply these two, product of these two ratios, you are going to get 1. This is the first observation. Sin theta times of cosecant theta is equal to, you have y by r times of r by y is equal to 1. Of course, none of them is a 0. Therefore, I can write sin theta times of cosecant theta is equal to 1, or I can write cosecant theta is equal to 1 over sin theta, or C, I can write sin theta is equal to 1 over cosecant theta. We can establish same relation between these two also, because they both are reciprocal to each other, and these two also. Okay, let me write it now. So this is second one. Tan theta times of cotan theta is equal to 1. Therefore, I can write cot theta is same as cot theta is equal to 1 over tan theta, or tan theta is equal to 1 over cot theta. And the next, third one, cos theta into secant theta, the both are reciprocal of each other, therefore their product also equal to 1. Therefore we have cos theta times secant theta is equal to 1, or cos theta is equal to 1 over secant theta, or secant theta is equal to 1 over cos theta. These are the first identities, the list of first identities in the trigonometry chart. We can have some more also. If you observe carefully, there is a relation between tan theta, sin theta and cos theta. What is that? Now, I'll take tan theta first. Tan theta is nothing but y by x. Now, I am going to divide this y by x, y and x both by r. If I do that, I'll get y by r by x by r. Now y by r is nothing but sin theta and x by is nothing but cos theta. So I can write this as sin theta over cos theta. Similarly, we have one more thing, that is cot theta. Cot theta is equal to, yes, reciprocal of that one, cos theta by sin theta. These are the very, very important fundamental identities. Please note down. Next one is one more very important, famous, well-known trigonometric identity. What is that? In any triangle, for any angle theta, we have sin square theta plus cos square theta is equal to 1. Now, proof is very simple. Proof. Consider a right angle triangle A, B, C. Right angle is at B. Let angle A is equal to theta. As usual, you have this is length is x, this is y, and this is r. Now this is a right angle triangle. Immediately you can apply Pythagoras theorem. Pythagoras theorem is applicable for right angle triangle. What is the Pythagoras theorem? The square of the hypotenuse is equal to sum of the squares of other two sides. So, in a right angle triangle, in the right angle triangle ABC, angle A is equal to theta, and AB opposite side is equal to adjacent side is x, BC opposite side is equal to y, and hypotenuse AC is equal to r. By Pythagoras theorem, we have x square plus y square is equal to r square. Okay, to prove my identity, I do some small manipulation. What I do, I divide both sides by r square. Then I get x square by r square, y square by r square is equal to 1. Or you can write y by r whole square, x by r whole square is equal to 1. Let this is 1. Now, I go to by trigonometric ratios. We know very well the ratio between y and r is sin theta. The ratio between x and r is cos theta. I make a list of that. And we have y by r is equal to sin theta, x by r is equal to cos theta. Let these two 1 sub 2. Use 2 in 1. We get in the place of y by r, I can substitute sin theta whole square. In the place of x by r, I can substitute cos theta whole square is equal to that one. You write sin theta whole square. This can be written as sin square theta. This square, this exponent is for entire sin theta, not only for sin theta whole square plus cos square theta also is equal to 1. This is the next most important, well-known, famous trigonometric. From this, we can establish other identities also. 2 more identities. They are number 1, secant square theta minus tan square theta is equal to 1. Another one, cosecant square theta minus cos square theta is equal to 1. We can derive both of them from the first identity, sin square theta plus cos square theta is equal to 1. So, proof or derivation. We know that sin square theta plus cos square theta is equal to 1. Now I am going to derive this first. What I do, I will write this cos square theta as 1 minus sin square theta. Just transferring sin square theta to that side. Dividing both sides by cos square theta. Dividing both sides by cos square theta. If I divide both sides by cos square theta, so we have 1 by cos square theta minus sin square theta by cos square theta is equal to cos square theta by cos square theta. So 1 upon cos square, reciprocal of cos is nothing but secant theta. Therefore, it will become secant square theta, and sin by cos is a tan, so tan square theta is equal to cos square by cos square is equal to 1. Hence, come to this one. Again, for this also, derivation. We know that sin square theta plus cos square theta is equal to 1. This time what happened? I keep sin square theta this side and I take cos square this side. 1 minus cos square theta. To get these results, I am going to divide both sides by sin square theta. So dividing by sin square theta. So we get 1 over sin square theta minus cos square theta by sin square theta, and this side sin square theta by sin square theta. Now 1 over sin square is nothing but cosecant square theta minus cos square by sin square is cos square theta, sin square by cos sin square equal to 1. Hence, now look here. Secant square theta minus tan square theta. It looks like identity a square minus b square, right? So I can write this as factors of two terms. What are they? Secant theta minus tan theta times secant theta plus tan theta is equal to 1. Just I wrote factors of these as secant theta minus tan theta, secant theta plus tan theta. Now, this is a real number. This is a real number. Product of two numbers is 1. That means they both are reciprocals to each other. Therefore, I can write secant theta plus tan theta is equal to 1 over secant theta minus tan theta, or vice versa. Secant theta minus tan theta is equal to 1 over secant theta plus tan theta. Of course, for no value of theta, the secant theta minus tan theta is 0, secant theta plus tan theta is 0, then only this rule is applicable. The same way here also we can have. So here also we can have cosecant theta plus cot theta is equal to 1 over cosecant theta minus cot, or cosecant theta plus cot theta, minus cot theta is equal to 1 over cosecant theta plus cot theta. Of course, we can derive some more also from this. We can derive some more also. We have secant square theta minus tan square equal to 1. Therefore, I can write secant square theta equal to 1 plus tan square theta. Or if you want, you can write secant theta is under root of 1 minus tan square theta. Or you can write tan as subject. Tan square theta is equal to secant square theta minus 1 or tan theta is equal to under root of secant square theta minus 1. This is another you can take. Now come to second one. Second one, cosecant square minus cos square equal to 1. So I can write cosecant is equal to 1 plus cot square theta, or cosecant theta is equal to under root of 1 plus cot square theta, or I can write cos square theta equal to cosecant square theta minus 1, or cot theta is equal to under root of cosecant square theta minus 1. This is another list. Please take up. Remembering the relation between any two trigonometric ratios really tough for beginners. Only if you have good practice, then only you can do it. Without trigonometric identities, you cannot solve any numerical question. So for this, I have a small technique how to represent one trigonometric ratio in terms of other trigonometric ratio. I can repeat how to represent one trigonometric ratio in terms of other trigonometric ratio for any angle theta. For this, I have a small method I have. For example, I want to express cos theta, tan theta, cot theta, secant theta and cosecant theta in terms of sin theta. This is my thing. I am going to establish a simple method. How I can express cos, tan, cot, secant, cosecant in terms of sin theta. Now we are going to express in terms of sin theta. So first of all, very simple. Let sin theta is equal to x. We are going to express all the five in terms of sin. So take sin theta is equal to x. I can write sin theta is equal to x by theta. Consider a right angle triangle. A, B, C. Now let this is theta. We have sin theta opposite side by hypotenuse x by 1. So I take this as 1x and this is 1. By using Pythagoras theorem, I can get AB as 1 minus x square. Now I have all the three sides in a right angle triangle. From this one, what is cos theta? Cos theta is equal to, you have AB by AC. Therefore, AB is equal to under root of 1 minus x square by AC is 1. Is nothing but under root of 1 minus sin square theta. So I have cos theta is equal to, I have root of 1 minus sin square theta. The next one, I am going for tan theta. Tan theta is equal to, you have BC, opposite side by adjacent side. So here BC is equal to, you have x and AB is equal to root over 1 minus x square. This is same as sin theta over root over 1 minus sin square theta. Next one, cot theta. I write here as cot theta, yes, reverse of this. So we have 1 minus sin square theta by sin theta. Then secant theta. Secant theta is AC over AB. AC is 1. So root of 1 minus x square and 1 minus x square is equal to 1 by 1 under root of 1 minus sin square theta. Then finally we have cosecant theta. Cosecant theta is AC by BC. This is nothing but 1 by x or 1 by sin theta. See, we could express all the remaining 5 ratios in terms of sin theta. You can establish that you can express other five trigonometric ratios in terms of cos theta by taking cos theta is equal to x. So my suggestion is no need to by add any trigonometric identity if you know this technique, and it is true for all values of theta. Theta can be either between 0 to 90 or 90 to 180 or 180 to 270, 270 to 360 or any angle. All these ideas are true for all the real numbers of theta. Please take this back.